I own a hardware store, and sometimes customers come in to ask me for some nails.
Hey, good morning. I'm building a deck in my house. I'm looking for about 1,000 nails.
Okay, 1,000 nails coming right up. 1, 2, 3, 4, 5. 998, 999, 1,000. So this is actually what happens when you ask for 1,000 nails at the hardware store.
Hey, I'm looking to build a deck, looking for about 1,000 nails.
Okay. Well, let me just consult my chart to see how long so 1,000 3-inch nails is. Okay. Looks like I'll need about 24 pounds. All right. That's 24 pounds of nails. There you go. So what you hopefully learned from that demonstration is that we can actually count by weight. And we do this all the time, either when you buy seed or when you buy nails or a lot of things, but we really do it in chemistry. Now, here's why we need to do that. Let's take a look at all of these things that we have here. I've got 8 things sitting here on my table. Now, what do they all have in common? Well, they are all 1 mole. Okay? So a mole is simply just a number. It's a grouping of different particles or a grouping of different things. So 1 mole is equal to 602 sextillion things, or sextillion. In chemistry, we think of this as 602 sextillion particles. So we will abbreviate this a lot as 6.02 times 10 to the 23rd. Okay? And so I'll remember that. We'll come back to that in just a second. But we'll use that a lot. That's how many particles or how many things are in a mole. So what I'm saying here is that if we have sulfur, silicon, tin, lead, water, and copper sulfate, all of these things all have different masses. They all have different volumes that you can see. They all take up different amounts of space. However, the one thing they have in common is they all have 6.02 times 10 to the 23rd particles. Okay? So, when I say particles, now we know that those can be different things. So, a particle, 6.02 times 10 to the 23rd particles, that could be either atoms, it could be molecules, it could be ions, we won't do that today, or it could be elements, right? It doesn't exactly matter. All of those make up 1 mole, right? You can have eggs, and instead of 12 eggs as a dozen, you could have 6.02 times 10 to the 23rd eggs will make up a mole of eggs. I'm hoping you're catching my drift here. So, now, what we're seeing here is that means that since there's 1 mole of sulfur, there are 6.02 times 10 to the 23rd atoms of sulfur here. Okay, because sulfur is just an element, right? So it's just got that 1 atom. Same thing for silicon, right here. And same thing for the tin. That's this stuff right here, my tin sticks. And then also same thing for my lead. Now, when we get to this part, this is water. Now remember, water is H2O. So we're going to say that there is 1 mole of 1 mole of water is 6.02 times 10 to the 23rd molecules of water. Because remember, it's got 1 oxygen and 2 hydrogens. We're going to treat that as 1 whole molecule. And then the last one is the copper sulfate. right? This blue copper sulfate. So copper is actually kind of heavy, so it's going to have, and sulfur is reasonably heavy, so one whole particle is actually going to weigh kind of a lot. So where do I find these numbers from? Well, you remember that chart we were talking about with the nails? This is exactly the kind of chart you're going to use. The numbers are straight off of the periodic table. So silicon, well, let's start with the first one. Sulfur, there are 32 grams in 1 mole. Where did I find that? I found that from the periodic table. Silicon, there are 28 grams in 1 mole. I find that straight off the periodic table. Tin, there are 118. And lead, that's 207 grams. Water, 18 grams. Probably the lightest. The lightest of these. And then copper sulfate, 250 grams. So we'll show you how we find that, but essentially you just go straight to your chart. Okay. Now we find it the average atomic mass, that number that's underneath the symbol, that is what's called your molar mass. Okay. So before we only called it the average atomic mass. This is your molar mass. That is how many grams, this is how many grams are in 1 mole of that substance. Okay, that's essentially what that's saying. So one quick thing I forgot to mention is that this concept of 6.02 times 10 to the 23rd particles was brought up by a guy named Ammonium Avogadro. We studied Avogadro's law earlier, and he was talking about the number of particles relating to the pressure. His experiments relating to the number of particles led to this discovery, so we call this number Avogadro's number. Avogadro's number. Now we call this, sometimes we abbreviate Avogadro's number, this part right here, as a capital N with a capital A as a subscript. Okay, just an FYI. So if you ever see me write that, that's what I'm talking about. Avogadro's number is a constant. It is 6.02 times 10 to the 23rd. All right. Miraculously, I've changed clothes, and I want to just tell you one last thing about the molar mass. We discussed that it was part of your chart, and this is your periodic table, and your molar masses are found on the periodic table by looking at the number underneath the symbol. Typically, it's going to have some decimal places. So remember that molar mass has a unit of grams per mole. So you can write that as G divided by moles. You can write it as G grams per mole here, or G mole -1. That's actually in Schoology. There's an option, if you click on the chemistry option, if it's a math short answer question, this is one of the units that you can select. But that's what that is. Inverse moles is 1 over mole. So what that's telling you is that when I look at that periodic table, let's say we're looking at nitrogen, element number 7, right? Atomic number 7. So nitrogen, I look underneath nitrogen and I find out that its molar mass is 14.007 grams per mole. Now, you'll find that most of these molar masses, at least for the lighter ones, are very close to a whole number. So we simply like to round it. This is your first chemistry class, so we'll only stick with whole numbers. So by the way, lead, let's say lead was 207.7 grams per mole. Let's go ahead and round that to 207 grams per mole. Okay, you get the drift? So that is essentially how you find that just for particular atoms. Just look up the molar mass that is on the periodic table, round to the nearest whole number, and you're done. Now that we have learned about the mole and we have learned about finding the molar mass of just different atoms, we now are going to look at the molar mass for different compounds. So as we learned earlier, the molar mass in a compound is the mass in grams of a substance that contains 1 mole, or Avogadro's number, of particles. Previously, we only considered atoms, and we used the average atomic mass of an element in grams as the mass of 1 mole of atoms. Now we are going to consider the mass of 1 mole of molecules, or formula units. The particles in a sample of a molecular covalent compound are called molecules. Okay, the particles in a sample of an ionic compound are called formula units. So this is technically a formula unit. Okay, even though some people will call it a molecule still, it is technically a formula unit. The molar mass of a compound is equal to the sum of the atomic masses in grams of the elements in a compound. So this is really simple. Calculate the molar mass of calcium nitrate, that's CaNO3. Now there's this 2 here. This 2 is going to distribute to everything that's inside that parentheses, because so there are 2 nitrogens and there are 6 oxygens. So essentially what we're going to do is we have calcium, and we know that calcium is right here. Molar mass is, zoom in, molar mass is 40. We have nitrogen, molar mass is 14. And then we have oxygen, which is molar mass is 16, rounding up to 16. So we want to calculate the molar mass of calcium nitrate. So we'll just take calcium, and then we will take nitrogen, and then we will take oxygen, right? We're just going to add them together. There is 1 calcium. Now there are actually 2 nitrogens, so we're going to do 2 times 14. We got those from the periodic table. And there are 6 oxygens, so the oxygen we said was 16. Okay, so when you get all that and you add those all together, 40 plus 2 times 14 plus 6 times 16, you get 164 grams per mole. Okay, and then now we want to calculate the molar mass of ammonium sulfate. Ooh, that's a little tricky because they didn't give us the formula, Mr. Russell. Well, we know that ammonium, okay, ammonium, let's see. Ammonium is not an element, it's a polyatomic compound, right? So ammonium is NH4, okay? And then sulfate is right there, and sulfate is SO4 with a 2 minus charge, right? That's on the back of that periodic table. And so ammonium's got that plus charge, and sulfate's got that 2 minus charge. We remember how to do this, right? So you take the 2 and you bring it down here. So we are actually going to need 2 ammoniums for every 1 sulfate. Remember that crisscross method? So we need NH4. We need 2 of those. And then we have 1 sulfate. So now we're going to look up our numbers. We're going to look up nitrogen, hydrogen, sulfur, and oxygen. So nitrogen is here. It's 14. Hydrogen is 1. Okay. Sulfur is 32, and then oxygen is 16. Okay, pretty simple, guys, right? So there are 2 nitrogens, so that's going to be 2 times 14, and there are 8 hydrogens, so 8 times 1, and there is 1 sulfur, so that's going to be adding 32, and there is 4 oxygens. Type that all into your calculator, and we end up that 1 mole of ammonium sulfate is equal to 132 grams, or the molar mass is 132 grams per mole. See, that's what that means. Simple enough. Have a great day.